All right, so this is again section 1.8. The inverse functions. So I think yesterday I stopped. There was an exercise. We had to find the inverse of a function, right? And I think we had like three problems. And oh yeah, Deverlin. Okay, thank you, Deverlin. I got you. Thank you. And I think we stopped. Solving the last one. So so let me just remind you definition of the inverse function if you you forgot. So let me just remind you. So what's the inverse of a function f? So the inverse of a function f of x. So the inverse of a function is a function. Okay, it's like a is a function, right? It's a function. Let's call this function g of x. It says that. So this function g of x, the inverse of f, satisfies the following. Yes, absolutely, Yani. So that's the 5 minus x over 1 plus x. Yeah. Yeah, I'm just first I'm gonna just remind you guys the definition of the inverse function in case of if you forgot the definition, and then I'm gonna go over again the problem. So it says that f. So here's the definition. So you need f composed with g of x to be equal to g composed with f of x, and both are equal to x. Okay. And we said we denote the inverse. So we denote the function g by f to the power -1. So the function g. So the inverse of f, it's denoted with f to the power -1 by f to the power -1 of x. All right, and then I think I explained how to you know how we can find the inverse of functions. All right, so so let me just remind you. So to find the inverse. So if you want to find the inverse of a function f, so we said like there are like 3 steps. So step 1. We said we have to replace f of x by y. In the step number 2, we said we have to interchange x and y. X and y. And then in the last step, we said we have to solve for y. Okay. So we said we have to solve for y. Well, at least to try to solve for y, because as I said yesterday, it's not always possible actually to solve for y. And so not all the functions have inverse. Okay, so try to solve for y. And as I said, that's not always possible. So that's not always possible. So when you solve for y, then y would be the inverse function. So that's the f to the power -1. That's not always possible. Anyway, so so the exercise was the last exercise was I think the following function. So exercise. So we had to find the inverse. So the inverse function of, so the function was, so f of x equal to 5 minus x over 1 plus x, if I'm not mistaken, right? Okay, so this is my function f, and I have to find the inverse. So first step, as a step one, we said we replace f of x by y. Okay, so here's my f of x. I'm gonna just write y instead of f of x. So this is now y equal to 5 minus x, 1 plus x, right? And then next, we said we have to interchange x and y. Okay, and this is step two, interchange x and y. So which means that y becomes x and x becomes y. So here's a y and here's a y. So that's the x would be equal to 5 minus y over 1 plus y, right? So that's my step number two. Last step now, which is kind of, sometimes it's tricky. I mean, depends on the problem, of course. I mean, it's, as I said, it's not always possible to actually solve for y, and it's sometimes it's just tricky to solve for y. So like here, I need to solve for y in this last step. And then, so there's a problem here, as I said yesterday, I guess. Well, my y, I have two y's. There's a y in the top, right? There's this y in the top in the numerator, and there's a y in the denominator, right? So even if you like, take the reciprocal, or you flip your fraction, you still have like a y in the top and y in the bottom, right? And again, the idea is, if you have to solve for y or for x or for wherever, you have to make sure that your variable is like always in the top. So if you have a variable in the top, in the bottom, in the denominator, you need to move the variable to the top. Okay, so there's this y in the denominator, so I need to find a way to move this y, so this one here, to the top. Okay, because I need to solve for y anyway. So what I said yesterday, so what we can do here is the following. So this is on the right side, we have a fraction, 5 minus y over 1 plus y. That's a fraction, right? This one here is it's a fraction, right? This is a fraction. So what I'm gonna do, I'm gonna divide the x on the left side by 1, okay? Because I want to make, so then x look like a fraction now, right? X over 1. So this is like a fraction now. And x over 1, of course, is just equal to x, right? When you divide by 1, you don't really change you don't really change your equation. So anyway, so we have these two fractions and they are equal. And when we have two equal fractions, so what you can do actually is to you can cross multiply. So when you cross multiply, then so then your x times the 1 plus y would be equal to 1 times the 5 minus y. Okay. So this is like a very general rule. So whenever you have two equal fractions, like you have like I don't know, like as I said, like 2/4 equal to 1/2, right? Then when you cross multiply, as you can see, when you cross multiply, well, 2 times 2 would be equal to 4 times 1. Okay, and that's well, that's true, right? And so the rule is that whenever you have like you know, a over b equal to c over d, and you cross multiply, then the a times the d would be equal to the b times the c. Okay. So this is like a very general rule. Whenever you have two equal fractions, when you cross multiply, it's still equal. Okay. Now, so why did I cross multiply? Because as I said, I want to move the y in the bottom to the, yes, Elizabeth.
For example, you put x parenthesis 1 plus y and equal. We don't put x, we just put 1 point parenthesis 5 minus y. We don't then again.
Yeah, I mean, first the dot, that's a multiplication, right? This dot here, this dot,
Yes,
it's that's multiplication.
but
Okay,
before
that's
that, we don't put the X like in the first one.
yeah. Here, you're talking about this X, right? So we have this X. So this
Uh-huh.
X, it's multiplied by, as you can see here, if you follow the arrow, this X is multiplied by 1 plus Y. So my X is multiplied by this
Yes.
this 1 plus Y.
We don't put like X, another X, like 2X.
No.
No. Okay.
No. So again, I cross multiplied. So I took this X, I multiplied by this 1 plus Y. Okay, and then that's equal. And now you multiply this one here by this 5 minus Y. So as I said, it's like you cross multiply. Right, and again, guys, why did I cross multiply? Because I want to move the Y, which is in the denominator, to the top. Okay, because otherwise I won't be able to solve for Y. Okay, I need all my Y's to be like, in the top. Okay, now I have my Y's, both Y's in the top. Okay, that's the good news. Well, I'm gonna solve for Y. So what I'm gonna do, I mean, whenever you want to solve for a variable, what you have to do, guys, is you have to keep your variable on one side and everything else to the other side. Okay, so like first I'm going to distribute, right? So when you distribute, this is like X times 1 plus X times Y, right? And here it's like 1 times 5 and minus 1 times Y. So this is like X times 1, that's X, plus X times Y, that's XY. And on the right side, I have 5 times 1 minus, because there's a minus here, 1 times Y, of course, it's just Y. All right, so what I was saying, guys, is I want to solve for Y, right? And my problem is to solve the Y. Now, I have this term with Y, and there's another Y here, right? And the idea is to move all the Y's, or the terms with Y, to one side, and everything else to the other side. So like this X here, this term here with the X, there's no Y here, right? This 5 here, there's no Y. Okay, so what I'm gonna do, I'm gonna move this Y to the left. Okay, and then I would have like my Y's, all my Y's on the left, and I'm gonna move the X, because there's no Y here in this X, I'm gonna move to the other side. Okay, the way to do this is, well, let me write again the equation, which is X plus XY, 5 minus Y. So as I said, I want to move this Y to the left side. So it's minus Y, so the opposite operation would be plus Y. So here's a plus Y. Okay, so this Y here cancel out. Okay, so that will be equal to, so this is X plus XY plus Y equal to 5. All right, so on the left side, I have Y here. I have another Y, but as I said, this X, this term here with the X alone, there's no Y. Okay, so I'm gonna move it to the other side. Okay, so the way to move to the other side is to, it's plus X, so I'm gonna subtract X. So minus X, minus X. So then we're gonna have, so this X cancel out. So then we're gonna have like XY plus Y, and then on the right side, it's 5 minus X. Right now, now I'm happy because I have all the Y's on one side, on the left side, and everything else without Y on the right side. Okay, this is 5 here, this is an X in here, there's no Y here, right? And the thing is, because now I have all the Y's on the same side, then the Y would be now like a common factor, right? So like on the left side, as you can see, guys, that's why I was trying to move all the Y's on the same side. So once you move all the y's on the same side, then y would be like a common factor. So now here, as you can see, my y is a common factor. So now y is a common factor. So that's why I moved the, like this x here to the right side, because there's no y here, right? So if there's no y, so it's not, so I cannot really factor out y because there's no y here, right? So that's why I moved the x to the right side, because there's no y in x. All right, so now y is a common factor, so I can factor out the y on the left side. So that's y times. Now, this is x times y. So here I need to multiply by x, right? Because y times x would be xy. There's a plus. So here's my plus. And here it's just y. So if you pull out the factor out the y, then you're going to end up with 1 here, right? Because y times 1, that will be equal to y. And on the right side, of course, it's again 5 minus x. So once you factor out the y, now guys, you can solve for y, because you can just divide. Yes, Joel, absolutely. So now I can divide. Absolutely. So now I can divide. You see here we have multiplication, right? Multiplication by x plus 1. So the opposite operation would be division. So we need to divide by x plus 1. And of course, we need to do the same on the other side. We have to divide by x plus 1. Right? And okay, so that's good. So then this x plus 1 cancel out. So now it's just y on the left. Just y on the left equal to 5 minus x over x plus 1. Yes, Joel, absolutely. So that's that will be the answer. So my inverse function, f inverse, it's actually equal to 5 minus x over x plus 1. Yes, Elizabeth. Yes.
I have a question. And for example, if we put like 5 minus, no, x minus 5 and 1 plus x is wrong?
Minus x plus 5 over
like x minus 5 and 1 plus x is gonna be wrong.
No, it's not exactly the same thing. Because no, it's not. No. It's not the same thing. X minus 5, that will be the opposite of 5 minus x.
Oh, okay.
You see,
they're different.
Yeah, they are different, of course, because as you can see, though, this minus 5. So here's my minus 5, and then minus x, that will be plus x. It will be this plus x here. So x minus 5 is the opposite of 5 minus x.
Okay. Thank you.
Professor, why do we have to? So why do we have to divide, do division of x
by?
Plus 1?
Why do we have to divide by the x plus 1?
Yeah.
Yeah, because you want to solve for y, right? And you have this. You have this x plus 1, so you have to get rid of this x plus 1, right? You wanna solve for y, so you need to get rid of this x plus 1. So that's why I divided by x plus 1.
No, you just chose it that way, okay.
And I divided because this is y times. So this is a multiplication by x plus 1, and the opposite operation would be division. So that's why I had to divide by x plus 1.
Okay, got it.
Okay. Sure. Any other question, guys? Do you want me to give you like a similar problem? Because I think it's not. This one is kind of tricky, and it's probably going to be in the test because the inverse functions they're going to be in the test. I think probably I should give you like a similar problem because it's really important that you know how to solve such a such a equation, right?
I was gonna ask how many exercises will be
in the test. In the test, I think it's gonna be about six or seven. I didn't decide yet. but it's gonna be about 6 or 7.
You know, 6 sounds better to me.
Yes, we'll see. We'll see. We'll see. But I mean, you are really good. I mean, it doesn't matter 6 or 7 or even 10. You know. All right, guys. So here's an another similar exercise. All right. So then just make sure that you know how to solve such problem. Okay. So exercise. I'm going to give you a little bit different functions. So let's say f of x. Let's see. Let's say it's 2 minus 3x actually. Okay. Over and in the bottom, let's say it's 4 minus let's see 5x. Okay, and you need to find, say, the inverse. Find the inverse of f of x. Right. So let's say you have 5 minutes, guys, to think about this exercise. Rabiul, you got the answer. Let's see. Elizabeth too. Oh, well, you guys, you have different answers. You have different answers, and Jewel. Oh, okay, Jewel, you have the same answer as Rabiul. So I actually I don't know the answer. I mean, I have to solve the problem first. But I see that Joel and Rabiul, you guys, you have the same answer. Elizabeth, you have different answers, so probably you got the wrong one. So let me see. I was minus the x. Oh, Elizabeth, that's the same. I mean, you just wrote the same function, right? Yeah, I think you just wrote the same function. Xing, I think, yes. So then, yeah, okay, then, yeah, Xing, then I think you're correct. So yeah, I think you, Joel, and Xing, you guys, you have a right answer. Joanna, you're saying, yes, I think it's correct. Yeah, very good. Very good, Joanna, too. Yes, that'll be correct, yes. No, you didn't. You don't really. You didn't really get a different sign actually, because I mean, your denominators, they have a different opposite sign, but the numerators also have different signs. So then it's just the same thing. But I don't know why. Lorden, yes. Lorden, let's see. Yes, Lorden, very good. I think you have the correct answer, yes. Okay, well, I think probably you're done, guys. That's a really good, good thing. Does anyone need more time? So if you're still struggling with this inverse functions, guys, please let me know. Please don't be shy. I mean, I'm here to help you. So if you're still struggling, yes.
Yeah, kind of stuck.
Mm-hmm. Which step?
I'm not sure if I did it right. I cross I put a 1 under the x, and then I cross multiply.
Mm-hmm.
And then I distribute it.
Mm-hmm. That's
then,
good.
I move 5xy to the other side.
Mm-hmm. Did you get like y as a common factor?
Oh yeah, I have to move to 2. 2. Okay. Yeah. Yes. Yeah. I got y as a common factor. Yeah.
Okay. Perfect. Then. And then you should divide, I guess, by your.
Okay. Oh, dang it. Oh, wait.
Yeah, I'm gonna go over it. Yeah, sure. Yeah, of course, I'm gonna go over it. Sean, did you get it?
Hold on, I'm writing it down. Hold on, I'm writing it down. I got this.
Okay. Well, I think there is a mistake with the sign somewhere.
What? Oh,
but it's almost. I mean, it's almost the answer, but there is a one mistake with the sign. I think it should be. I think should be minus 5x in the denominator. It should be. I think it should be 3 minus 5x in the denominator. I mean, you almost got the answer, but just there's a should be minus 5x. Anyway, so I'm gonna go over it anyway. So okay, so let's see. So first, as I said, so f of x, becomes y. So this is now y equal to 2 minus 3x over 4 minus 5x. And then you interchange x and y. So y becomes x, and x here becomes y. So equal to, there's this 2 minus 3y and 4 minus 5y. All right. Now, as I said, the right side is a fraction. You need to make the left side, make it look like a fraction. So I'm going to divide this x by 1. It doesn't change the equation, right? When you divide by 1, and then you cross multiply. So let's see here. So you cross multiply. So now it's like x times 4. Don't forget the parentheses, guys. That's really important. Okay, so 4 minus 5y, 1 times the 2 minus 3y. Okay, let's distribute. So this is x times 4. So that'll be 4x. There's this minus, so it's minus 5xy, right? So it's x times 4, that will be 4x, and then x times the 5y, so that will be the 5xy, right? And on the right side, it's just 2 minus 3y. All right, so I'm gonna move the y, all the y's to the left side. So there's this 3y here, right? Minus 3y. Okay, I'm gonna try to move it to the other side. So it's minus 3y. So the opposite operation would be plus 3y. So it's plus 3y both sides. Okay. So now, so it's 4x minus 5xy plus 3y. And on the right side, we have like minus 3y plus.
From the Great Barrier Reef Marine Park Authority. So, Julie, would we be able to hand on over to Fred?
Okay, I guess. Okay, I guess that's not related to the lecture. Minus 3y plus 3y, so it cancel out. So it's just equal to 2 here on the right side. Okay. Now, guys, I got all my y's on the left side, right? This one here, but there is this 4x, right? There's this 4x. So here there's no y, okay? So because there's no y there, I need to move the 4x to the other side. So when I say move, I mean you have to do like the opposite operation. So this is like plus 4x. So I need to subtract 4x. So minus 4x. Minus 4x. So now it's like, so this 4x here cancel out. So now it's like minus 5xy plus 3y equal to 2 minus 4x. All right, now I got all the y's on the same side and everything else to the other side. Okay, so now, as you can see, my y is a common factor. So if my y is a common factor, so I'm happy because I can factor out the y. So for the first, in fact, you pull out y, so you are left with minus 5x. So this is minus 5x. There's a plus, so I'm going to put a plus. And you pull out y here, then you are left with 3, right? So this is plus 3. And on the right side, it's just the same thing, 2 minus 4x. Okay. Now, I'm going to just divide because, as I said, this is multiplication, right? So the opposite operation would be division. And I'm going to divide, of course, by the same thing, both sides. Okay, so then my y would be equal to 2 minus 4x over minus 5x. So as I told you, Sean, I mean, your answer is almost correct. It's just it should be minus 5x instead of plus 5x.
Professor, if there's a minus on the denominator, doesn't that make the whole fraction negative?
You're talking about this minus one, minus this one?
Yeah.
No,
No, that's what I got, and I move it to 4 because that's what makes the fraction negative, right?
Nope, it doesn't really make the fraction negative.
The fraction's not-
Because unless you wanna like factor out the minus, like so what I'm saying is like you have minus 5x plus 3, right? And this is 2 minus 4x. So the one thing you can do is like if you factor out the minus, so it's like minus 5x, and then there will be a minus 3 here. You see, because now you have like, you know, this minus minus, that will be this plus. So now, because you have minus, this is like minus the whole denominator. Here, it's just minus the 5x. It's not minus the whole denominator, right? So this, because of this parenthesis here, so this is like minus the whole denominator. So then, so we have this 2 minus 4x. So then you can move this minus to the top, for example. You can move to the top. So then you have to take the opposite of the top. And the opposite of the top would be like minus 2 plus 4x, so over 5x minus 3. Yeah, but again, the minus in front of the 5x, it doesn't make the whole fraction negative, or unless you factor out the minus, like what I did here. Okay.
Would it be correct if you do it like that as well?
Yeah, of course, and it would be correct. Yeah, sure.
Professor, how come we cannot factor the 2 minus 4x?
You mean you wanna factor out the 2?
Yes,
Like,
that's what I did. I got
yeah, you can. Yeah, you can do that too. I mean, here you don't really you don't really have to factor the top. I mean, you don't really, because even if you factor the 2, factor out the 2, but I mean, it doesn't really simplify the expression, right?
Yeah.
I mean, it doesn't change almost anything. So it's correct, of course, it's correct.
Okay, that's what I wanted.
Yeah, it's
to know,
correct.
because
Sure.
that's what I did. All right, thank you.
Okay, sure.
So
I mean,
Professor,
yes.
if there's a 1 over negative 2, it's not negative 1 over 2.
If there's like 1 over negative 2.
Yeah, does that mean it's not?
That's what I'm saying. So you see the thing here, this negative, it's like that's minus the whole denominator. Here the denominator is just 2, right? So this is minus the denominator. So then yes, so there'll be like minus half, or negative 1 over 2.
Yeah.
You're right. But what I'm saying is that if you have 1 over minus 5x plus 2, this minus, you see this minus, it's not minus the whole denominator. The whole denominator should be like the 5x the plus 2, right? It's not, it's just minus 5x. It's not minus the whole denominator. That's why I cannot really move this minus to the top.
Okay.
You see what I'm saying?
Yeah.
The way to do it is, if you want to really move the minus to the top, you have to like factor out your minus, like minus 5x, and then it would be minus 2. Minus 2, that would be this plus. So this minus now, it's like minus the whole denominator. And then, yes, I can move it to the top, or put it in the front, or whatever. Okay? All right, guys, are there any other questions? I think I missed something in the chat. I'm sorry if I didn't. Okay, Rabi, you're saying, oh yeah, of course, yeah, go all different sides. You're correct. Yes, Rabi, right. Okay, guys, very good. Okay, let's just finish this section with one more thing. I mean, just to show you, like, from a graph of a function, how can we determine whether the function has an inverse or not, right? Because remember, guys, not all functions have an inverse. Okay, that's really important. So the question now is, given a graph of a function, how can you determine whether the graph of the function has an inverse? All right, so that's the next question, and then we can move to the next section. So next question is the following. So given the graph of given the graph of f of x, given the graph of f of x, so how can we determine? I mean, if you have the equation of f of x or the function f of x, you can say whether the function f of x has an inverse or not, right? We can try to solve, we can try to find the inverse. Now we are trying to see if you have the graph of the function f, how can you determine whether f of x has an inverse? Okay, because as I said, not all the functions review. I didn't understand the constant part of the function inverse. Yes, we said because we cannot solve for y, so then the constant function has no inverse. Yes, Safa. It doesn't exist. So if f of x is equal to 4, the inverse, it doesn't exist. There's no inverse. It has no inverse. Does this answer your question, Rabiul? Okay, perfect. Safa, you have a question, I guess. You raised your hand, or just by accident? I guess probably it's just by accident. Yeah, so I was saying not all functions have an inverse. Okay, so that's so you need really to keep in mind, guys, that this is not all functions have an inverse. Anyway, so let me just explain the idea, and then I'm going to show you with the graph how it works. Okay, so the idea is the following. It's very simple. I'm going to just take remember, like, let's say you have two sets, right? This is the first set, that's the inputs, and this is the second set. This is a set of outputs, right? And let's say, like in the first set, I have 2 points, right? And this second set, I have 1 point, all right? And then I have this function f, so my f of x, so like this point goes to this one, right? This is my function f of x. And this point here goes to this one, right? So, I mean, this correspondence or this relation here is a function because remember, guys, I mean, each input has exactly one output, right? It doesn't matter if the two inputs have the same output, it doesn't matter, right? But what's important is that each input has exactly one output, right? So this is a function, right? Now, this is a function f, and I want to find, let's say, the inverse of the function f. So how do we find the inverse? Well, as I said, the idea behind the inverse function is that we want to switch the output with the input, right? So in other words, you want to reverse the arrows. So like, if I want to find the inverse of this function f, so what I will do is I'm going to reverse the arrow. So like, I'm going to go, so let's say I'm going to go now from this point to this one. So so you have to reverse the arrow here, and I have to reverse this arrow as well. Okay. So that would be like the inverse function, because as I said, the inverse in the inverse function, what we do is we switch the input with the output. So now it's like we have this correspondence. So we get the following now. So on the left, I have, so my set of inputs is this one here with 1 point. And the set of outputs, I have these 2 blue points. Okay, and what I'm saying is that so this point here, it goes here and here, right? So it goes here and here, right? Now, my question for you guys is this correspondence a function? Well, the answer is no, because as you can see, this input has like two different possible outputs, right? So this is not a function. So this is not so this is supposed to be the inverse. This is supposed to be the inverse function, the inverse of f of x. But this is not a function, okay? Because this as you can see, this input has two possible outputs, right? So it's not a function. So this function f has actually doesn't have an inverse. So f of x doesn't have an inverse. Okay, because again, because when I reverse the arrows, okay, the new correspondence I have here it's not a function, because as you can see, our input has like two possible outputs. So f of x doesn't have an inverse. So what's the problem here? The problem is, as you can see, for f of x, these two inputs, they have the same output, right? This one, and that's okay. I mean, for a function, it's okay. You can have like a function with like two inputs having the same output. Okay, so for example, let's take f of x equal to x squared. So f of x equal to x squared, if you do f of +1, that will be +1 squared. So that's +1, right? And if you do f of -1, that's -1 squared, which is -1 times -1, which is also +1. So as you can see, guys, +1 and -1, they have the same output, which is +1. Okay, so let me write it down here. So x +1 and x -1 have the same output, y, which is equal to 1, right? So that's exactly like here in this situation, right? I have, let's say this is like -1, this is +1, and both they have the same image, which is +1. So it's okay for a function to, you know, to have like inputs with the same outputs. Okay. Now, can we find the inverse? Now, so the question is, does f of x, this x squared, have an inverse? Okay. So having an inverse, it means that I can reverse the arrows, and I still get a function, right? So let's see if x squared have an inverse. Well, so let's just try to find the inverse of x squared. So y is equal to x squared. We interchange x and y. So this is x equal to y squared. But then when you solve for y, so you have to apply the square root here, there's a square root here, and because the even power, then you're gonna need the plus or minus. So when you solve for y, you're gonna have y equal to plus or minus square root of x. Okay, and this is supposed to be the inverse function, right? This is supposed to be the inverse, but this is not a function, right? So this is supposed to be the inverse, the inverse functions. But it's not a function, but it's not a function because of the plus or minus. So, which means that we have like two possible answers or two possible outputs. So it's not a function. So the conclusion is that this x squared, it doesn't have an inverse. So the conclusion is that f of x equal to x squared doesn't have an inverse. And so what's the problem here? Why f of x doesn't have an inverse? Well, the thing is because as you can see, these two inputs, +1 and -1, they have the same output. But if you reverse the arrow, okay, then the correspondence you get, it's not a function, like as I explained here, right? When you reverse the arrows, then the correspondence you get is not a function. So the problem is, so if you have a function where like two inputs have the same output, then the function actually doesn't have an inverse. Okay, so this is like very general statement. So the let me just write it down here. So the idea is, so if two inputs have the same output, then the function doesn't have an inverse. Two inputs have the same output, then so two inputs x, of course, have the same output y, then the function has no inverse. Okay. So now let's check the graph of x squared. That's like, so for the graph of x squared, so the graph so this is, let's say this is 1, 0, 1, -1. Say this is +1, 2, etc. This is, let's say 4, etc. -2. Anyway, so I'm gonna just try to graph x squared. So 0 squared is 0, 1 squared is 1, -1 squared is +1, 2 squared is 4, etc. And -2 squared is +4. All right. So anyway, so here's the graph of x squared. Okay. So as you can see in the graph of x squared, +1 and -1, they have the same output, right? The same output, which is +1 right here. Okay. So if you take this horizontal line, this yellow horizontal line, right, it intersects the graph at 2 points. So which means that +1 has actually two inputs, right? The +1 here and the -1 here. Okay. So
so it's not that there's no actual value, is that since it's the same one, you say that it doesn't have one?
Yeah.
Okay.
Yes. Yeah. And actually, that's actually the idea here. So whenever you have like a horizontal line, like let's take this horizontal line, for example, at when y is 4. Like this is, let's say this is y is 4, right? So this horizontal line intersects the graph at these 2 points. So which means that the 4 has two inputs, right? The -2 and +2, right? -2 square and +2 square, both are equal to 4, right? So because my horizontal line intersect the graph at 2 points here, it means that 4 has two inputs, right? The 2 and -2. And that's why actually this function f x squared doesn't have an inverse. So in general, so if a horizontal line intersect the graph at more than 1 point, then the graph or the function f has no inverse. So in general, if a horizontal line just one horizontal line intersect the graph at more than 1 point, more than one, so it's 2 or 3 or more than one, at more than 1 point, then f of x has no inverse. So for example, as an example, let's take the following graph. Let's say I have, let's take 2 examples. So first example, let's say I have the following graph. For example, this one here. Okay, let's say this is my f of x. All right, and the question is, does f of x have an inverse? Okay, so I can just apply this, what I call the horizontal line test. So this is what I call the horizontal line test. Okay, so if one horizontal line intersects the graph at more than 1 point, then you're done. Your f doesn't have an inverse. Well, down here, if you take this horizontal line, of course, intersect the graph at just exactly 1 point, which is okay. Here, still okay. I just have one intersection, but like here in the top, I'm gonna have like 2 intersections, right? So because of that, this function f has no inverse. Yes, doesn't have an inverse. And again, the idea, guys, is that that's because, as you can see, the output y here, I don't know, let's say this is 3, for example. The 3 would have like 2 possible inputs, like this one here and this one here. So 3 would have like 2 possible pre-image or the inputs. So yeah, so this function f here, f of x, doesn't have an inverse, it has no inverse. Rabiul, you were talking about the constant function. So if you just take example number 2, just take the constant function. I'm gonna just take f of x equal to 2. Okay, so let's say this is 1 here, this is 2. So what does it mean f of x is equal to 2? It means that any input x, for any input x, the output is gonna be the same, which is 2. All right, so like if this is my input x, the image would be 2. If this is my input x, the image would be also 2, etc. So for any x or input x, the image would be 2. All right, etc., etc. So the graph would be just like a horizontal line, which passes through the 2. Right, that's my f of x equal to 2. All right, so that's what I call the constant function. Constant function because the output doesn't change. The output is always the same, which is 2, right? That's why it's called constant function. Anyway, so does the constant function have an inverse? Well, obviously it's just a horizontal line. So if I take just, this horizontal line here, well, it's just it's going to intersect the graph at all the points, right? And obviously, so then f of x has no inverse. Okay, because it's just the graph, it's just a horizontal line, right? So, last example, an example which has an inverse. So example 3. For example, f of x equal to x cubed. So if you try to graph x cubed, then the graph would look like something like this here. Right. So let's say this is my f of x. And in this case, of course, take any horizontal line, it's gonna intersect the graph at exactly 1 point. Right, just 1 point. So yes, Rabiul, absolutely. So this graph has an inverse. So this function f has an inverse. So f of x has an inverse. All right. So so anyway, so the idea here, guys. So if you have a graph and you want to check if the function has an inverse, all you have to do is to use this horizontal line test. So the horizontal line test is different from the vertical line test. Remember, we have this vertical line test to check if the graph is a function or not. So this is different. This is a horizontal line test. Okay, if you want to determine whether a function has an inverse. All right, is there any other question, guys? So, I mean, I guess this horizontal line test is not really really hard. Is there any question, guys, about this horizontal line test? Okay, no questions. Okay, perfect then. All right, so then I guess we can move to the next section because we are done with this, the inverse. Yeah, I think we did a lot of examples. Yeah, I think we are good. So yeah, let's just move to the next section. So next section, it's included in the test. So let's do the section. I'm gonna do the section 2.2, which is very short, actually, a very short section. So we're gonna move to the chapter 2 and do the section 2.2. Which is very short. Okay. And it's about quadratic functions. So what we're gonna do, the goal of this section is to graph, as I told you guys, I mean this course, it's all about graphing functions, right? So in this chapter 2, we're gonna see how to graph like quadratic functions, polynomial functions, rational functions, etc. In chapter 3, we're gonna see how to graph like exponential and logarithmic functions. And in the chapter 4, we're gonna see how to graph trig functions. All right, so it's all about graphing. So anyway, yeah, but I would say quadratic function is not really hard. So first, what's the quadratic function? Well, it's just a function of the form, ax squared plus bx plus c, right? So functions of the form f of x equal to ax squared plus bx plus c are called quadratic functions. And the goal of this section is to learn how to graph. So the goal today, so the goal of this section is to, so how do we graph quadratic functions? So I'm going to show you the steps. All you need to graph quadratic functions, right? So how do we graph quadratic functions? Actually, graphs of quadratic functions, they have a name. They are called parabolas. Okay, so graphs. So graphs of quadratic functions. Because they look like a parabola, right? So are called parabolas. Okay, so let's do a couple of examples, right? So I would say the simplest example would be, of course, here, guys, there's an important remark here. Your A, this A here has to be different from 0. Okay, A is different from 0, right? So the A it must be different from 0. A is different from 0, right? So this is different or not equal to 0. Because if A is 0, of course, 0 times x squared would be 0. And so the x squared would just disappear, right? If A is 0. Okay, so A it must be different from 0. Anyway, so let's take very simple examples of quadratic functions. Examples. So I'm gonna do, let me do two, I would say the two most important examples. So first example, let's just do x squared. F of x equal to x squared. Or let's, instead of x squared, let's say it's x squared plus 1. So x squared plus 1, of course, this is, this is a quadratic function because it's of the form, we have like 1. So the A would be equal to 1, right? What will be B? What will be B in this case? Right, so we are supposed to have like ax squared plus bx plus c, right? So there's no x here. Yeah, Lord, very good. So b here in this case is 0 because there's no x, right? So if there is no x, then b is 0. And then of course c is just the constant was positive 1. Yeah, thank you, Lord. So this is obviously a quadratic function because it's of the form ax squared plus bx plus c, where a is 1, b is 0, and c is 1. Anyway, so I'm gonna just try, just to graph this function. I'm gonna plot like a couple of points and see the, try to study the graph of this function, right? So let's make a table of values. Let's say this is my x, this is my f of x, right? Which is of course x squared plus 1. So for example, let's say x is let's take, for example, x equal to -2. All right, so then f of x would be, so -2 squared, 4 plus 1, that would be 5. -1, then -1 squared, that's positive 1 plus 1, that's positive 2. 0, 0 squared plus 1, that's positive 1. 1 squared plus 1, that's 2. And let's say positive 2. 2 squared plus 1, that's positive 5. Anyway, I'm just, I took random points here just to graph, my function f. So I guess, so I'm gonna need 0. This is my 0 here. 1, 2. This is positive 1. And then I'm gonna need 5. So 2, 3, 4, and then 5. So 1, 2, 3, 4, 5. Let's say this is 5, all right? This is -1, -2. Anyway, so yes, Eliani, that's what I was saying. This is going to be in the test. So today's lecture is in the test, yes. And actually, in the review sheet, there is a question about the quadratic functions. Yes, it's gonna open. Yes, it's gonna open up like you, absolutely, Joel. So that's actually the, yeah, absolutely. That's like the shape of the graph, absolutely. So, what I was saying. So yes, here, so 0, 1, -2, we said +5, -1, we said it's +2. Oh yeah, I need +2 here. +2 here, same here, and same here. All right, so I'm gonna just join these points and all right. I don't like my, no, it's not, this is not, this is -2. So the image is 5, it's here, sorry. 5 here. All right, so now it looks better. All right. So this is the graph of my function f. So this is my f of x equal to x squared plus 1. Right. So as Joel said, so the shape of the graph, so it's a parabola. That's what I call a parabola. It's like a sort of like a capital U, right? And as Joel said, it opens up, right? This is really important. So this parabola here. So the parabola opens up. Okay. And the reason why it opens up, it's because the A is positive. So my A, my A is +1. So whenever A is positive, then the parabola is going to open up. If A is negative, we're going to see the next example with A negative. If you have A negative, then the parabola is going to open down. Okay, so so this is like very general remark. So if A is positive, come on. So if A is positive, then the parabola opens up. Okay, and if A is negative, the parabola opens down. Okay, so this one here, it opens down if A is negative, right? Anyway, so in my example, A is positive, right? So A is +1, so it opens up. What else? Yeah, there's like a special point. You see this like lowest point here in the parabola, this one here. So this point is called this lowest point in the graph. So this point here, well, obviously it's it's a global minimum, right? And so this point is called actually the vertex of the parabola. Okay, so this is this point is called the vertex of the parabola. So if you have a parabola, right, which opens up like this one, the lowest point of the graph, that will be your vertex. That's the vertex. That's what we call the vertex of the parabola, right? And so in general, there's a formula to find the coordinates of the vertex. So like here in this example, what will be the coordinates of this vertex? So this is the point. So the x here is 0, right? So as you can see, the x is 0, and yes, as well. So the x is 0 and y is 1. Okay, so this vertex, it has the coordinates. So x is 0 and the y is +1. So that's the point 0, 1. Okay. So this vertex, which is a global minimum, right? So it has the coordinates 0, 1. So yeah, as I said, there's like a general formula to find the vertex of a quadratic function. I will give you later the formula. But anyway, so there's this special point, the vertex. What else? Yeah, there's one more thing here about the parabola. As you can see, like this parabola is symmetric about the y-axis, right? This is, you see this, the y-axis, this vertical axis. This is what I call the y-axis, right? This is the y-axis, and you can see the distance of the points from the y-axis are kind of similar. Like the distance, like this point here and this point, they have the same distance from the y-axis, or like this one here, it has the same distance from the y-axis as this point here, right? So the y-axis is kind of like a mirror between the two parts of the parabola, right? So as you can see, like if you take these 2 points, for example, well, I mean, I know my graph is not perfect, but as you can see, the distance from this point to the y-axis is the same as the distance of this point to the y-axis, right? Etc. Yeah,
You
yes.
just said that the local minimum will be called vertex in this case,
Yes,
right?
yeah. It's actually global. So this is, it's
I mean, yeah,
actually
right.
global. Yeah. So this is, it's actually a global minimum. Yes, global. And global minimum. So it's a global minimum when the parabola opens up, but I'm gonna see in the next example when the parabola opens down, then you're gonna have like a global maximum, right?
Exactly.
All right, so now let me just give you an example, guys, where the parabola opens down. Okay, this parabola here opens up. Next example. So example number 2. So I'm gonna take f of x equal to, so let's say minus x squared plus plus 2, or plus 2. Okay, let's just say plus 2. Right. So if you want to graph this, I'm gonna just take a couple of points. So this is f of x, which is minus x squared plus 2. So I'm gonna take, as usual, like -2, -1, 0, 1, 2. So for -2, well, here be careful, guys, because for example, f of -2, right? Well, so first there is this minus x squared, right? So this is minus first, and then we have x, right? This x here. So inside my my circle, we're gonna have yes, Rabi was gonna open down, yeah. So inside, so I'm gonna have my x, which is -2. So here I'm gonna have my -2, right? Square, and then plus 2. And the circle is like parentheses. So this is like minus, and then -2 squared plus 2. Okay. Now, guys, PEMDAS rule. So we think of this minus here, this one here, as like a subtraction, and then you have like parentheses with the power square. So of course, parentheses and exponent, they comes first, right? So they before the subtraction. So it's first, this is equal to, well, first I'm gonna do the -2 squared. So what's -2 squared? Well, -2 squared is like -2 times -2, right? That would be +4, right? And then there's a minus here. I'm gonna keep the minus, and then there's +2. So the answer here, -4 + 2, that would be -2. Okay, so just be careful. So what I'm saying here, like f of -2 would be actually equal to -2. It's not 6, right? It's -2. So the answer here is -2. -1, it's the same thing. So we're gonna have like -1 squared, which is +1, but there is a minus outside, right? There's this minus which is outside the parentheses. So it's actually in -1 + 2, which is +1. F of 0, well, 0 squared minus 0, so it's just 0 + 2, that would be equal to 2. For 1, it's the same thing as -1. So it's going to be +1. And f of 2, 2 squared, that's 4, minus 4 + 2, that would be -2. Anyway, so I'm just saying, so for the graph now, so let me just graph. I'm going to graph this f of x. So I'm going to need +1. So I'm going to need 0. So this is my 0. Let's say this is 1. This is 2. -1. This is a -2. And I'm going to need positive. I'm going to need 2. I'm going to need +1. And then I'm going to need -2. So this is -1. This is -2. Anyway, so f of -2 is -2. So this is my -2. F of -1 is +1. F of 0 is 2. F of 1 is +1. And finally, f of 2, it's again -2. So it's somewhere here. All right, so let me just connect these points. Hopefully it's a kind of symmetric. So I'm just connecting these points. All right. And so as you can see, guys, because in this case, the A, it's negative, right? A is -1 here, right? A is -1, right? AX squared plus BX plus C. So A is -1. So because A is negative, then the parabola opens down. All right, because A is negative. A is negative. Now, what about the vertex? Well, here again, so there's this special point, which is, well, because the parabola opens down, so we're gonna have like a global maximum, which is, yes, Joel, absolutely, this is 0, 2. So this point here, so that's what I call the vertex of the parabola. So that's my vertex. So the x is 0 and the y is 2. And as I think, yes, it's 0, 2, very good, Lorden. So, and this is actually a global, it's the highest point of the graph, obviously, right? This is gonna go all the way down. So this vertex, it's actually a global maximum. All right. And again, we have like sort of a symmetry about the y-axis. Well, here it's not because the graph is not really good, but we are supposed to have like symmetry about the y-axis, as you can see here. We are supposed to have like, so the symmetry about the y-axis. So so the y-axis is is an axis of symmetry. Okay. Right. So that's an example where the parabola opens down, right? Because the A is negative. Anyway, guys, so this is like just 2 examples. Now I'm gonna give you like the, all the steps how to graph quadratic functions, right? So in general, yes, Eliani, absolutely. So either, yeah, it's either global maximum or global minimum. Yes, the vertex is always, yeah, either global max or global min. Yes, absolutely. So in general, so first, to graph a quadratic function, so first we need to find the vertex. And we have a formula for the vertex, the quadratic function. So we need to find first the vertex. And actually the coordinates of the vertex is always given by minus the x, it's given by minus b over 2a. Okay, and the y is just f of minus b over 2a. Okay, so the x, the coordinates of the vertex, the x is always minus b over 2a, and the y is just of course f of this minus b over 2a. Okay, so that's like the formula for the vertex. And so if a is positive, then the vertex is a global minimum, right? And of course, the parabola opens up. Right? And if A is negative, then the vertex is a global maximum. If A is negative, then the vertex is a global maximum. And the parabola opens down. Okay. And then you need to find, in general, so we need to find the x-intercept. So we need to find the x-intercept. So how do you find the x-intercept? You just solve f of x equal to 0. So it's just a quadratic equation, right? F of x equal to 0. Fourth, step number 4. We need to find the y-intercept of the graph, and it's just f of 0. So find the y-intercept. So it just so just evaluate f of 0. And last thing, guys, as you can see, there's this axis of symmetry, and actually the axis of the symmetry, it's just a vertical line which passes through the vertex, right? So the axis of symmetry, it passes through the vertex. Well, it's not always 0, Joel. Well, in this case, yes, it passes through 0, but it depends on the vertex. Of course, I'm gonna give you an example later where the vertex is not like on the y-axis. But yeah, so the axis of symmetry, the axis of symmetry is a vertical line passing through the vertex, passing through the vertex. Right? And the vertex, we said the general formula for the vertex, it's a minus b over 2a. So so the axis of symmetry is just is the same formula as the vertex, is x equal to minus b over 2a. Okay, and then of course you have to use all these informations to graph your parabola or your quadratic function, right? So let me do an example. I'm gonna try to follow these steps and show you how to use all these informations, you know, to graph my quadratic function, right? So here's an example. So example. So let's say my quadratic function is, so f of x is equal to x squared minus 2x plus 1. Right? So of course this is a quadratic function because, well, I mean, as you can see, a is, you know, a is positive 1, right? Because here's a positive 1. B is, you know, negative 2, so b is negative 2, and the c is positive 1, right? So it's a quadratic function, right? Right, so first thing to do is to find the vertex, as I said. So step 1, or first, we need to find the vertex. So find the vertex. Okay. So how do we find the vertex? As I said, that we have a formula. The vertex should be the x coordinate of the vertex. It's minus b over 2a. Okay, so that's the formula for the vertex. It's the x coordinate, it's minus b over 2a. So x so the x coordinate of the vertex, it's minus b over 2a, and that will be equal to, so minus b minus, so b is negative 2, so I'm going to use parentheses for negative 2, that's a negative number, over 2a, so it's just over 2 times 2, sorry, 2 times 1, a is 1, right? A is 1. So that will be equal to, well, it's positive 2 over 2, right? So x is equal to 1. So we are saying the x coordinate of the vertex is 1. What about the y coordinate? It's just the image of 1. So the y coordinate of the vertex is f of 1. F of 1 because I got 1 here as answer, right? Minus b over 2a is equal to 1, right? So that's why I'm computing, evaluating f of 1, because I got x equal to 1, right? So that's why I'm computing f of 1. And what's f of 1 is just, you know, 1 squared minus 2 times 1 plus 1. And that will be equal to 1 minus 2 plus 1. So it's negative 1 plus 1. That will be 0. So the vertex, the x of the vertex is 1, and the y of the vertex is 0. Okay, so the answer here, the vertex would be the point 1, 0. So the vertex, so this is the answer to the first step. So the vertex is x is 1, and y is 0. Right? This is my x, and this is y. This is x, and this is y. So that's the 0.10. Input is 1, output is 0. All right, so we got our vertex. Next, we have to say whether, you know, the parabola opens up or down. Well, here obviously A is positive, right? So if it's positive, then the parabola opens up. So number 2, my A is positive. So the parabola opens up. So it's positive. So the parabola opens up. And so my vertex would be like, you know, a global minimum. And vertex is a global, is a minimum. All right, and then next, what else we need to do? We have the vertex, we know it opens up. I have to plot the x-intercepts and the y-intercept. So x-intercepts, we just solve f of x equal to 0. Remember, guys, the x-intercept, that's the intersection of the graph with the x-axis. So in this third step, we have to find, and then of course, we're gonna plot the x-intercepts, right? So we need to find the x-intercept, and it's just, you have to solve f of x equal to 0. Okay, so my f of x, of course, just x squared minus 2x plus 1 equal to 0, right? Of course, you can use the quadratic formula if you want, right? You can use the quadratic formula, or you can just say, well, this is x squared minus 2x plus 1. This is like x minus 1, the whole thing squared. But anyway, let's just use quadratic formula, okay? So it's minus b plus or minus square root of b squared, you know, minus 4ac over 2a. Right, so you apply the formula. So minus b would be minus -2. That would be +2, plus or minus square root of, so b squared, that's 4, -2 squared, that's 4, minus 4 times a times 1 times c, which is 1. So it's just 4 minus 4 over 2a. So it's 2 times 1. So 4 minus 4 is just 0. Square root of 0 obviously is 0. So it's just 2 over 2. So actually we got just one x-intercept. There's one solution here, only one answer, which is +1. So because 4 minus 4 is 0. So there's one x-intercept, which is 1. So the answer here for the x-intercept, so the x-intercept is 1. And remember, for the x-intercept, the y is always 0. This is always 0. Always 0 for the x-intercept. Again, guys, x-intercept, that's the intersection of the graph with the x-axis. Intersection of the graph with the x-axis. Okay, that's what I mean by the x-intercept. Okay, we are almost done. The y-intercept, well, y-intercept, that's the intersection of the graph with the y-axis. So we need to find the y-intercept. So that's, again, intersection of the graph with the y-axis. Okay. So the only thing you have to do here, y-intercept is very easy actually. Just evaluate f of 0. Just find f of 0. What's f of 0? So my f of x, of course, guys, was x squared minus 2x plus 1. That's my f of x. So if x is 0, so we're going to have 0 squared minus 2 times 0 plus 1. So the answer is positive 1. So in the y-intercept, the y is equal to 1. So the answer, so the y-intercept is, so y is 1 and x is always 0 in the y-intercept. So x is always 0. Okay. So anyway, so we're almost done. That's the y-intercept. And finally, just one word about the axis of symmetry. I mean, axis of symmetry, we said it's just the same as it's a vertical line passing through the vertex. So it has just the same equation as the vertex. So I'm just writing down here. So the axis of symmetry is just the same axis of symmetry.
Can you scroll up?
Excuse me?
Can you scroll up?
Oh yeah, sure, sorry. So the axis of symmetry is just a vertical line passing through the vertex. So it has the same equation as the vertex. So is x minus b over 2a, which is just the same as the vertex, which is equal to 1, right? This is 1. Okay. Again, so this axis of symmetry, just a vertical line passing through the vertex. Through the vertex. So, okay, we are done with all the steps. So I have actually all the information I need to graph my function f. I have the vertex, I know the x-intercept, the y-intercept. I mean, I know my axis of symmetry. So, and I know that my parabola is going to open up. So I'm going to just try to sketch, of course, your graph, guys. I mean, in the test, your graph doesn't have to be perfect. I mean, mine, it's not perfect, right? So you have just to sketch, give find like the shape of the graph, right? It doesn't have to be perfect. So let's see. So like here, so I'm gonna graph now. So let's graph now f of x, which is x squared minus 2x plus 1, right? So we said the vertex, let me just write down here the information I'm gonna use. I know the vertex, we said the vertex, it's 1, 0, right? Axis of symmetry, we said just as it passes through the vertex, so it just x equal to 1. We said it's gonna open up. It's a parabola which is gonna open up, opens up. We said the x-intercept, just 1 point, which is 1, 0, which is the same as the vertex actually. And finally, the y-intercept, we had just a 1 point, which is, y-intercept is just 0, 1, right? So I'm gonna plot these points and try to graph my quadratic function. So I would say the most important point is the vertex. You need to know where is your vertex, and you need to know if the parabola opens up or down, okay? So like here, in this case, this is 1 here, 1 here, 1 here, etc. So first, we are saying that the vertex is 1, 0, right? So here's my vertex. It's x is 1, y is 0. So here's my vertex. All right. I'm gonna plot the x-intercept. X-intercept is the same as the vertex, is again 1, 0. There is also y-intercept, which is 0, 1. So here's my y-intercept, it's a 0, 1. And there's this axis of symmetry. Axis of symmetry, right, which is x equal to 1. So the axis of symmetry is supposed to, it passes through the vertex. So here's my axis of symmetry. So this is my vertex, and so here's my axis of symmetry. Right, and this is my vertex. Okay, and I know the parabola opens up, so I'm gonna start from my vertex. This is my vertex, which is supposed to be a global minimum, right? Because the parabola opens up. So I'm gonna start from the vertex. I'm gonna go like here from the left. I'm gonna go to this point because it's the y-intercept. And let's say I'm gonna have like sort of a U here, sort of capital U, starting from my vertex, right? And so should be like something like this here. All right. So this is the graph of my f of x. So all you have to do, guys, you plot your vertex, you plot your x-intercept or y-intercept or wherever, all right? And then you start from your vertex, right? And then, of course, you have to make sure that you, if your parabola opens up or down, right? So like in this case, it opens up because my a is positive, right? So if it opens up, I'm gonna start from, you can start from your vertex and you go just like, you go up and you draw like a, you know, sort of like a capital U, right? Starting from the vertex from this point here. And that will be your graph, okay? Again, it doesn't have to be perfect. Just plot your x-intercept, your y-intercept, your vertex, and then, yeah, that's it. Is there any question, guys, about the graph here? How I got the graph, or? Again, main point is to find the vertex. Once you find vertex, then just you draw like sort of capital U starting from your vertex. And of course, make sure that you connect the x-intercept and the y-intercept. All right, guys. Is there any question about this? So this is going to be in the test. So we're going to have a problem about graphing a quadratic function for sure. Okay. Because it's really, yes.
There's no points that we need to like, I mean, plug in here, or I'm not
No,
sure.
I mean, you see what I plot here, I plot my vertex, right? This one here, and I plot my y-intercept, which is 0, 1. And then I have to plot my x-intercept. Well, it's just x-intercept is the same as the vertex, right?
Okay.
So, I mean, all you have to do is just like start from the vertex and draw like a capital U starting from your vertex, and that's it. I mean, you don't have, I mean, as I said,
It was always lead you to whatever side it is, so I'd see.
but again, because it's.
I mean, if you
know,
start
this-
from the vertex and exactly,
Yeah.
and then you go to that point, it's always gonna be either to that side or to the other one. Is
Yes. Yeah.
I
Yeah.
get it.
Yeah. Because it's supposed to be symmetric. You know, about this this line here passing through the vertex, right? So it's like this line is it's like a mirror, right? So you start from the vertex, you know it opens up, so you go up. So if you go up on this to this side here,
Yeah,
so
yeah, I
of
see.
course you have
So-
to go up on the other side here.
Once you get to the back vertex, pretty much the other side is gonna be the same.
Yeah, absolutely, yeah. Yeah, so yeah, guys, so this is gonna be in the test. You need to know how to graph quadratic functions. So let's take a break, and then I'll give you like an exercise or something, right? Let's take a break. It's time for a break. Let's take a break 10 minutes, and I'll be back at in 10 minutes, right?
Professor, can you please
Yes.
scroll up?
Oh yeah, sure, please. Yeah, of course. Is that okay, or
A little bit more up.
little bit more up, okay.
Not all the way to the quadratic formula. Yeah,
Quadratic formula, all right.
yeah.
I guess here,
For some reason,
right?
I wrote something down wrong. Okay, right there. Thank you.
Sure. All right, guys, be back in 10 minutes.
Professor Tiffany, can you,
Yes.
I wasn't here when you was taking attendance, so if you could just mark me.
Oh, yeah, please.
I'm a little bit late. It's Tiffany Rodriguez.
Tiffany, yeah, Tiffany, all right. Thank you, Tiffany. Thank you for letting me know. Yeah, thank you. I got you. Thank you.
And you're still recording.
You're right. Thank you. Still recording.